This lecture video is about chemical bonds and the different ways in which elements can actually join together or be attracted to each other in order to form molecules. So before we get into the nitty-gritty of how chemicals will connect with each other, there are a couple things that we just need to know, like just to remind ourselves before we get started. The first thing is everything about chemical bonds has to do with the electrons, okay? For all practical purposes, we're ignoring the protons and we're ignoring the neutrons. Like everything that's going to happen now in terms of one element combining with another element is going to involve some kind of interaction of the electrons, okay? Those negatively charged particles. The second thing is that we always have to remember that elements want to have a full valence or outer shell of electrons. That makes them the most stable, okay? But not every element, which we learned last week, has a full outer shell. So basically, chemical bonds and the connections between two different elements is going to be what each element needs to do in order to get that full valence outer shell, okay? So there are essentially three possibilities that can happen. An element may have to give up electrons in order to have a full shell. It might have to pick up electrons in order to have a full shell. And in either of those cases, now our element has a charge to it, right? If it gives up an electron, it becomes a positively charged ion. If it picks up an electron, it becomes a negatively charged ion. And again, take your periodic tables out, you guys, and look at those. You already know these, right? We did this last week, okay? You know that these elements here are going to want to be +1. So every element in this group is going to want to give up an electron when it binds with somebody else. Okay, this was +2, right? It wants to give up 2. This is how beryllium will get an outer shell of electrons if it gives up 2 electrons, because then that next shell, that next lower shell, becomes completely full. So again, use your periodic tables to help you with this because we already know what every single element wants to do. Fluorine, it's going to want to pick up an electron in order to be stable. We know what each element is going to want to do just based on its location on the periodic table and when looking at those charges, which we talked about last week. So, second, chemical bonds are formed when two or more elements, like I said, either give or take electrons from each other. This is going to be called ionic bond. This is the type of bond that we will start with. Or whether they share electrons. So some chemical elements can say, hey, I need 1 electron to be stable. You've got 1, but I don't want to make you unstable. So instead of giving and taking, we're just going to share them in order for both of us to have a complete outer shell. Okay, and this is called a covalent bond. The second thing that's going to be helpful for you to know, and again, keep those periodic tables handy, is knowing where the nonmetals and the metals are, okay? Because this is going to make a really, really big difference for you. These were all metals. You know, everything that was over here are going to be metals. Everything over here was going to be nonmetals. This is going to be important because, for instance, ionic bonds only happen between a metal and a nonmetal. So just by looking, if I said to you, hey, is iron going to form, what kind of bond will iron form with, let's say, sulfur? Okay, well, the fact that iron is a metal and sulfur is a nonmetal, then I would think to myself, oh, that's probably going to form an ionic bond, okay, versus covalent bonds, which don't typically form between metals and nonmetals. So keep your periodic table handy as you kind of look at some of these different ideas and structures.